Hi, everyone. Thanks for joining that session. This is the first of today's P7 user conference. And as first presentation, we have the pleasure to welcome Sandeepak Nathu from SimData. The topic is about, let's say, giving you the let's say an overview on the market, and as SimData is one of these specialized company and doing market studies, and they have a deep understanding of the market and its evolution in various domains. Could be PLM, SPDM, CAE, globally speaking. Sandeepak, thanks a lot for joining us and accepting to present at our user conference. The floor is yours.
Thank you very much. A very good morning to all of you. I would start with a brief introduction about SimData. SimData is a strategic management consulting company working in this field of product lifecycle management and digital transformation. We work with our clients mainly to desire, acquire, and deliver and support innovative products and services. We have been in the industry for last 40 years, and we reach out to the industry with primarily three offerings. Research, which is essentially market research in the domain of product lifecycle management and technology. Then we arrange a number of conferences, certificate programs, as well as seminars and webinars. And we also provide consultancy services for both software companies as well as end user industrial manufacturing companies. With that background, let us dive into today's topic. I'm going to briefly talk about simulation analysis market trends, and then followed by technology trends. Then briefly going to cover the fact that simulation is evolving as an enterprise asset, and it's becoming more and more a lifecycle solution than just a verification and validation solution. Then broadly going to touch upon the various needs of engineering platforms, and then share a few conclusions. If you look at the overall happenings of the simulation analysis industry for the last year or so, what we can clearly see is that the industry has actually grown quite significantly by about 11%, even in these tough economic conditions. If you look at, I would say, the market leaders, ANSYS, MathWorks, Dassault Systems, Siemens, Altair, all these companies, Hexagon, all these companies which have a rich legacy have maintained a market leadership position. There is tremendous amount of M&A activity happening in this industry, and there's a huge, I would say, consolidation happening across the board. Then, if you look at importance of platform technologies, it is growing, and interest in platform technology is primarily driven by digital transformation as a theme is growing quite rapidly. I would not read out all of these points here, but simulation analysis industry is actually becoming quite important. Just as a milestone, I would like to mention that the revenues from simulation analysis actually crossed CAD software sales revenues last year, which in my opinion is quite a milestone event and quite a noteworthy event, given the fact that simulation is still not as penetrated as, let us say, CAD. The opportunity for adoption of simulation in industry is actually huge, and we believe that in over the next 10 years we are going to see a tremendous amount of growth in this particular space. If you look at the numbers more from a industrial penetration perspective, essentially there are no surprises here. Automotive and aerospace dominate the market in terms of adoption of simulation technology and have a market share of about 50%. Then over last 5 years or so, we have seen tremendous increase in interest in terms of electronics, semiconductor, high technology, all kinds of telecommunication technologies getting involved in traditional, let us say, mechanical engineering, civil engineering technologies. So that sector is also actually growing. If you look at closely, and if you merge the electronic sector along with the telecommunication and satellite and electromechanical sector, it is becoming a significant part, to getting closer to 20-25% of the market. Just to make another point here, uh, even in the automotive and aerospace industry, if you look at from an application perspective, uh, electronics applications are actually growing, but by sim data, I would say methodology, we count them as automotive or aerospace revenue. But even the automotive and aerospace is now kind of dominated by lots of electronic, semiconductor, electromechanical type of analysis technologies. Process industry is also growing, but may not be at the same pace at rest of the industries. But adoption of simulation technologies as a vehicle for digital transformation is a theme that we are seeing across the board. With that brief overview of the market trends, let me move over to the more important part in today's presentation. Uh, what we do is we track technology trends in the simulation analysis industry, and I would like to delve a little bit deeper in these technology trends. What we are observing is that model-based systems engineering, which is something that came about 10 to 15 years back, but had seen a sluggish growth, is becoming actually a more and more important technology. A role of model-based development, right from requirements to operations and after sales, is becoming critical, and we see industrial customers adopting this methodology more and more as products become more and more complex. Moving ahead on the same theme, we see that startup companies which are innovating, let's say, new products, along with more established companies, are looking at multiphysics, core simulation, system simulation technologies in a much more, I would say, interested manner. Uh, Primarily, this is driven by product complexity. If you look at, let us say, let's say, traditional mechanical machinery today, uh, companies are wanting to make that machinery intelligent, with certain amount of telecommunication, with certain amount of inbuilt intelligence, and that is leading to the need of having multiphysics, or let's say physics simulation within, having multiple let's say equations being solved within the same solver, or integration of two solvers, let's say by having some sort of an API exchange, or having system simulation or mixed fidelity simulation, which is either empirical formulas or ordinary differential equations, or let us say 1D, 2D equations representing a certain class of physics, and different class of physics is represented by, let us say, 3D physics. So all these high fidelity, mixed fidelity models are becoming more and more important. And this again, I would say, ties back very well into our theme of this conference today, of in terms of having a platform available to achieve some of these visions. Then the third trend that we are observing is digital transformation. And digital transformation is not just a technology trend, but it is also encompassing the business aspects of running any business operation. And technologies such as digital twin or a digital thread are becoming more and more popular, so that people can actually, or managers can connect the technology performance of the product with respect to the business performance of the organization. All of this essentially generates a huge amount of data, and integrity of process and data across organizations, in terms of being able to maintain consistency, being able to have an access to all the relevant data when in the time of need. It is it is becoming critical, and that is what is driving increase in adoption of simulation and process data management technologies. The next set of technology trends that actually we are observing is the generative optimization, implicit modeling, and additive manufacturing trend. This is actually leading to having access to technologies to companies which allow them to conduct, let us say, large scale customization, or products which were not possible to be, let us say, manufactured, let us say 10-15 years back, are possible to imagine today and are able to be manufactured today. So this is actually having a huge impact on the industry, and it is primarily driven by infusion of simulation technology across the entire product life cycle. Generative design, optimization, implicit modeling, and additive manufacturing, all of these tie in very well with respect to adoption of simulation in industry, and of course, let us say, having a platform as a backbone to realize some of these products. Then we cannot forget the fact that AI and ML is playing a very, I would say, broad role across the entire industry, and is becoming more and more critical. And physics-based simulation, along with AI and ML, is becoming more and more mainstream. Cloud computing and SaaS is a trend that we have observed over the last 7 years or so, and is now becoming actually mainstream, particularly for smaller companies, and even larger companies are going for private cloud solutions, which allow them the flexibility of having the data security and privacy on one side, but at the same time having flexible infrastructure. We are also seeing a lot of convergence of mechanical, electrical, electronics, and simulation technologies coming together in a simulation environment. If we take a step back here and try and find a common factor within this all technology trends, what we can see is that on the right hand side, you can observe that what I'm representing here is a picture developed by US Federal Highway Administration Authority, which represents the entire V cycle of product development. Traditionally, simulation has played a role on the right side of the V as a verification and validation tool. But if you look at all these use cases that are emerging today, simulation is actually starting to play a larger and larger role across the entire product development, right from requirements analysis up to after sales service. We believe that this is primarily driven by organizations feeling competitive pressures, and then leading to having shorter design cycles to respond to rapidly evolving customer choices. Then number of companies are observing new market opportunities, and they want to address those market opportunities as quickly as they can. So this is again kind of driving the trend towards adoption of simulation across the entire life cycle of the product. And there is an ever increasing demand of lower cost products, primarily due to let us say inflationary pressures, as well as environmental impact considerations. So when we look at lower cost products, we don't necessarily mean in terms of products which require a less amount of money to manufacture, but overall having a less footprint or less cost, even from an environmental perspective. So if you broadly look at all these trends, what we can see is that product development is becoming highly infused with simulation technologies, which is driving to the need of having an enterprise level platform which can enable you to achieve this vision. So driving a little bit deeper into this trend, another thing that we are observing is that there is tremendous amount of data that is getting created across the entire life cycle of the product, and organizations are requiring to maintain a certain level of digital continuity, what is broadly being referred as a digital thread. And the platforms that are being conceived or being implemented are requiring to, let us say, maintain this data flow across the entire product life cycle, as well as integrate that information flow across already implemented enterprise level solutions, such as PLM solutions, as well as ERP solutions and supply chain management solutions. So the new age simulation platforms are requiring to integrate themselves with the organization's digital thread by having, let us say, connectors with PLM, with ERP, and with supply chain management solution. So with that in the background, what I'm observing, or as SimData we are observing, is actually a technology backbone need of having single and multi-physics simulations under one platform, then design space exploration as another category of simulation requirements, then creation and dissemination of workflow across the entire organization, having experts create workflow so that the entire organization can benefit from that workflow, and it can be systematically implemented across various functions. Then having your internal high performance resources, licensing tools, as well as external HPC resources available under that, let us say, one platform with mixed environments involved, is also evolving to an important need. Then connecting all of this with new age data science libraries, data engineering tools, digital transformation technologies, IoT initiatives, and what is being broadly called as a digital twin of products and processes within the same environment is also becoming very critical. And process and data management technologies with connection to PLM systems is also something that is very critical. What we are seeing is that enterprises now, based on this, are requiring to have a technology backbone which can help them realize all of these objectives with one umbrella solution. If we look at these things more from a let us say business impact perspective, because ultimately organizations are not going to invest unless and until they see real term monetary impact in terms of being able to deliver more cost effective solutions, or increase profit or reduce design cycles. Uh, we believe that these technology platforms can act as a single source of truth of models, workflows, and data across the entire organization. Traditionally, simulation, as I mentioned, was used only by the design and verification departments. But as we see, let us say, situations like COVID emergencies emerging, even supply chain management function may want to conduct, let us say, simulation for replacement of an existing material that is no longer available and is being used by the product. So those functions are also seeing value in using these technology platforms which enable them to conduct these live simulations. uh, uh, and it is becoming more and more critical that the existing asset that the industry has invested in terms of simulation is being made available more and more across the entire organizational functions, which eventually can lead to improved quality and cost savings and overall scalability of usage of simulation across the entire product lifecycle, as well as the organization. So, in summary, what I would like to highlight here is that with increasing product and process complexity, simulation analysis is playing a greater role across the entire product lifecycle. It is being employed as a strategic asset. Uh, to be able to do or achieve this vision of simulation acting as an enterprise asset, organizations require a collaborative engineering platforms which have open APIs, where the possibility of interacting with other tools, HPC functionalities across, let us say, data, people, and best practices is becoming very critical. Many organizations are realizing this with the help of verticalized applications, applications which solve a particular class of problems, as one would call as a democratization of entire simulation. That has been that is also one theme that has been playing for a very long time. And it all of this requires a robust technology and IT backbone, which can create eventually business value for the organization. So in the end, what I would like to say here is that engineering platforms are becoming very, very critical to realize simulation as a strategic asset. And during this entire day, across this entire set of presentations, I would like you to observe, and I would encourage you to observe and take away things which you feel are more important for your organization. So with that, I will end my talk, and I'll be happy to answer any questions if you have.